Hello everyone and welcome back to another video. In this video we're going to discuss what a limiting reactant is and how to solve a problem while considering the limiting reactant. So essentially if we wanted to define limiting reactant, it's the starting substance or whatever initial reactant you have that becomes used up first, or it's consumed first, or you basically run out of that stuff first when a reaction occurs. This limiting reactant controls how much or how little product can be formed. So if you think about a combustion reaction, it's not necessarily that, fires happen forever. Eventually that fire runs out of fuel. And the fuel, or really the fuel, technically you consider the reactants. You have either your hydrocarbon or you have the oxygen. Well, we have a ton of oxygen in the air around us. So the oxygen really isn't the problem, right? It's running out of the fuel, it's running out of the wood, or running out of the paper, or running out of the gas, or whatever it might be, that usually causes a fire to extinguish. And if you think about like a forest fire, for example, what do firefighters try and do? They try and limit the amount of oxygen that basically can be consumed by the fire to keep the fire going, because seemingly there's a limitless amount of firewood in the forests, and you can try and engulf the air around it. So fighting a fire is very similar to trying to identify a limiting reactant. I got to eliminate one of the two things to stop the reaction from happening. We can also relate it to baking as well. Let's say I'm using a family recipe to make a cake where it requires the following ingredients here on the left. But let's say my kitchen contains these ingredients. As you know, your kitchen very likely doesn't contain a limitless amount of flour, eggs, sugar, etc. Maybe water, because water comes from the tap. You could technically have a ton of it, but not necessarily unlimited. But here's what I want you to do. I want you to read through these sentences here and try and answer the following questions. Looking at your recipe and how many ingredients you have, how many cakes can you make? Which of these ingredients is limiting your ability to make more cakes? Because remember, you can't make half a cake, you got to make a full cake. So figure out which ingredient you would run out of first. And then let's consider one separate ingredient. Let's think about eggs. How many eggs would be left over after making that amount of cakes? So hint, hint, eggs would not be your limiting reactant. Pause the video, take a few seconds, and try and figure it out. Okay, hopefully you figured it out. How many cakes could you make? You could make 3 cakes. Which ingredient limited you to only make 3 and not 4? That would be your flour. The recipe requires 2 cups of flour, but you only have 7. So that means you could only make 3 cakes, because 3 times 2 would give you 6 cups, and you couldn't make a 4th cake because you would need 8 cups of flour. Can't make half a cake. How many eggs would be left over after making the cakes? Well, if it takes 2 eggs per cake and you make 3 of them, that means you used 6 eggs. If we compare that to the 2 dozen eggs we have, 2 dozen eggs is 24. So 6 compared to 24 means I would have 18 eggs left over. And this idea of baking and something that's limiting your production is very similar in chemistry too. Let's take a look at an example problem and how to approach it. So here, I'm going to give you a balanced chemical equation. It's basically ammonia reacting with oxygen to generate nitrogen monoxide as well as water. And if you balance the equation, you get the following mole ratio. You have 4, 5, 4, and 6. Let's say that I have 3.25 grams of ammonia and I have 3.5 grams of oxygen. So essentially what I'm trying to figure out is how much product am I going to get? What would be my limiting reactant? What's going to be consumed first? Let's say I want to figure out how much nitrogen monoxide am I going to get? Well, how would I approach this? The simplest way to do this, in my opinion, is to convert your quantity of grams to moles and then compare it to how many grams of product you would get. Whichever is the least amount of product, that's your limiting reactant, because that's the maximum you could make. So let's go through that process. So essentially we're doing a mass to mass problem, but for 2 different things. We're doing mass to mass for ammonia and mass to mass for oxygen. So if I have 3.25 grams of ammonia, I need to first figure out how many moles of ammonia I have. So I'm going to divide that by the molar mass, which is 17. Once I'm in moles of ammonia, it's a 4-to-4 ratio, which is the same thing as a 1-to-1 ratio, right? If I multiply by 4 and divide by 4, it's the same thing as multiplying by 1, dividing by 1. Now, once I'm in ammonia, or once I'm in nitrogen monoxide, I gotta figure out how many grams that would actually create, assuming I have an infinite amount of oxygen. Well, if I do 1 mole gives me 30 grams, I would find that I could get 5.74 grams of NO. And again, we're doing this to basically hold one thing constant. So I'm holding that I have 3.25 grams of ammonia, but I'm assuming I have an unlimited supply of this. Now let's do the reverse. Let's say I have 3.5 grams of oxygen, but I have an unlimited supply of ammonia. Same process. I'm going to first divide by the molar mass of O2, which is 32 grams. Then I'm going to use the mole ratio, which in this case isn't 4 to 4, it's 5 to 4, so I can't just reduce this to 1 to 1. And then once I'm in moles of NO, I'm going to then figure out how many grams I have by multiplying by the molar mass. So if I do my math, 3.5 divided by 32 times 4 divided by 5 times 30, I get a mass of 2.63 grams. Well, which one is my limiting reactant, and which is the amount that I would actually get? It's going to be this smaller amount here. The amount of mass I would have generated is the 2.63 grams of NO. So which is my limiting reactant? It's my oxygen. 3.50 is my limiting mass of oxygen. I would say that the ammonia here is in excess, or I have an extra amount than I need. I could actually have less ammonia and still get the same amount of product. I could probably have 3 grams or maybe 2.75 grams. You could do the math and figure out, what that actually has to be by doing more mole conversions. But essentially, my oxygen is my limiting reactant and my ammonia is in excess. What's the most NO you can make? 2.63 grams. Which reactant is the limiting reactant? Oxygen is. Which one is in excess? Your ammonia. Thanks for tuning in.